Welcome, guys. Welcome to the course TCP/IP. Today, we will be discussing about the MPLS benefits in traffic engineering. Before this video, what we have discussed? We have discussed about the traffic engineering. What is traffic engineering? What is the process of traffic engineering? So let's start with the benefits of the traffic engineering with the help of, let's say, MPLS technology. Now, let me start with the first one. So here, definition, we can recall this particular definitions of the traffic engineering, guys. Traffic engineering is in MPLS involve the technique of directing traffic that flow within a network. So here, our purpose is what? Directing a traffic. So we are giving the way, that is traffic engineering giving the way to that particular flow on the internet so that the resources can be used effectively and the traffic can manage. So we can have this definition simple terms. Several routing procedures implement packet forwarding for the secure transmission, as like, let's say, static routing, dynamic routing, circuit switching, packet switching. These all IPsec is also available. So these are all the mechanisms are available with the for the secure transmissions. And these mechanisms are incorporated in MPLS as well as in traffic engineering. Ultimately, traffic engineering is what we can say. It is what the uh, divergence of the traffic, or let's say maintaining or managing a traffic over the internet. Then there are some advantages of the traffic engineering over here. So let's take the first advantages. The first advantage is minimize the network congestion. So what do you mean by network congestion? Congestion is what if the many packets or many segments are going to be passing from one place, that is with choke up kind of things is available. That is what the congestion. So that the packets can be lost and traffic is more. So that is what the congestion. An MPLS network can implement traffic engineering to curtail the network blockage and boost up the performance. So here, MPLS technology used for the traffic engineering to curtail the network blockage. So whatever the heavy flow is available, if there is heavy flow is available, so it is going to be reduced. It is going to be reduced, and then once it is reduced, so it is going to be boost up the performance, guys. Okay. Second, the MPLS traffic engineering allows exploitation of bandwidth in use rather than allocating new bandwidth to operate traffic engineering, which leads to less latency, jitter, and the loss factors. So, what is available with the traffic engineering? Whatever the bandwidth available with us that is underutilized or overutilized, that is going to be used effectively rather than allocating the new bandwidth. Because if we allocate new bandwidth, so it is going to be underutilization. Okay, so proper utilization for the proper utilization, what we are doing, we are using that bandwidth for the effective purpose, so that the latency will be very less, jitter also will be very less, and the loss factor will be we can see the removed. Okay, so this is what the minimize the network congestion. Talking about the second disadvantages, MPLS fast reroute for link or node failure. So what if the node is failed or linked or failed? Then automatically rerouting is supposed to be there. So and that rerouting is available with the MPLS traffic engineering. Here, MPLS fast rerouting functionality handles link or node failures by directing encapsulating traffic to a pre-configured secondary path when primary ones fail. So once the primary, let's say there are two paths available, if this is collapsed, so automatically the traffic is going to be passed from this particular second alternative path. This is not possible in case of the IP network, as redirecting mechanism is not applicable over here. Okay, so this is what the drawback of IP packet forwarding. The highlight in MPLS assures that highest reliability and network uptime with the appropriate mechanism to recover from network congestion and other bottlenecks. Okay, so here it is always uptime. So immediately, whenever there is a failure occurs, automatically the things are going to be rerouted, or things are going to be alternative available, we can say. Okay, because our purpose of the traffic engineering was we are focusing on what the bandwidth, we are focusing on the bandwidth rather than only the shortest path. So this is what the two advantages. Let's talk about the another advantages. Here, second will be a deployment facility, a deployment flexibility. A traffic engineering system is efficient even when the MPLS network implemented in under development. Okay, then offices with the multiple branches over the globe make most of the deployment flexibility with a different combination of the connections. So deployment is possible with the different combinations. It is flexible during the situation when the overflowing packets from the link are transferred to the available links. Okay, so it is also flexible in this case also. So flexible in terms of the diversion of traffic, rerouting, managing a traffic, everything is going to be flexible over here. And deployment flexibility means what? At runtime and any time, the deployment can be possible with the easy maintenance and easy kind of things. So this is what the deployment flexibility, because ultimately if the link is available only, so if the link is fell, let's say, and link is, let's say, overflow and then fell, so we have to establish the second alternative path, and if the path is not available, the deployment is supposed to be there in a very fast nature. So deployment flexibility is available. Then class of service, COS. This is what the 3-bit field available in a MPLS labels, like say, that determine the class of service value based on which the traffic in its priority queue for its use for transmission. And at the egress edge, that we have entrance edge, the arriving IP packet is marked with the COS, that is class of service value, and they are encoded for reference in MPLS header. So what is the egress edge? If whatever the incoming IP packets coming to the MPLS network, that is what the egress edge, where that egress routers we can say, and that will be marked as a class of service, in the MPLS header. This provides a fast packet transmission between nodes to avoid the network congestion. So network congestion can be overcome due to this particular facility. The function of COS are committed access rate, that is CAR, weighted random early detection, that is WRED, and weighted fair queuing, the WFQ. These are the services. Each service class implement traffic engineering by classifying the traffic based on available bandwidth in links, manage the packet, overflow in edge router, drop probability, and network traffic control using algorithms like round robin. So what is there? Whenever the packets arrive at the MPLS network, here the class of service is going to be labeled to them. On the basis of the class of service, the priority queue, and what kind of service to be there, that is going to be decided. Once it is decided, it means what? We are using the proper bandwidth. What we have discussed in traffic engineering process, where everything is statistics is collected, and then it is optimized. Then it is optimized that what to do, how, what not to do, how to do, and how not to do. Okay, everything is going to be available, so that the probability of dropping will be less. The network traffic will be using for different kind of round robin algorithm, so that everyone get the fair chance. So if we get it weighted where fair queue, everybody will get the fair chance. Okay, weighted random early detection, so error can be detected at earlier stages. Okay, access rate supposed to be there. So this is what the class of service, and this class of service is going to be very important in a customer satisfaction, or maybe the identification of any other errors kind of things. Okay, so there is a next advantages: customer traffic identification. MPLS traffic engineering classified the customer traffic based on the service provider use in MPLS network. As we discussed in a class of service, it is classified based on the service providers. Okay, okay, then this is only due to what? The class of service feature of the technology, MPLS technology, that does traffic categorization. So what we are doing, we are categorizing all the services, we are categorizing all the kind of traffic to the different portions, or different what can say, the groups. Okay, so that it is going to be easier to maintain over. So this is also the advantages. Then let's talk about the limitations of the traffic engineering in MPLS by using, or let's say, MPLS. Very first limitation is what? Overutilization of secondary link. What happened at the instance of the link failure? Fast rerouting of the MPLS traffic engineering use backup tunnel to reroute the traffic over the secondary links. So if there are two links are available, if one failure, so we are using alternative links. So in that case, overutilization of that secondary or alternative link can be happen, because it is immediately transferred the load of first one to second one. If there is already load available in the alternative path, so it may be get overloaded. Okay, while this is a configured setup for recovery, recovery, the performance is completely complete only if those tunnels comprise sufficient bandwidth. But it is taken care, that is, if the bandwidth is sufficient, then only the rerouting can be possible. Okay, then a satisfactory level of free capacity is necessary for smooth functioning. In spite of the backup method, frequent failures of the network nodes will lead to the constant traffic congestion on alternative paths, reducing inefficient overall. So ultimately, this is not a limitation. We can say if the link is failure, the route is going to be rerouted, path traffic is going to be rerouted. So all the considerations are taken care with this LPI. With this, but in worst case, the alternative path may get overutilized if the already available task is already the traffic is available in that route, and additional traffic is going to be added over there. Then manual path setup. To implement traffic engineering, path required manual configuration irrespective to the presence of the internet protocol for the packet routing. So this is what the limitation. Physical path computation is possible by denoting the consecutive hops occurring from a source to destination path. So we have to calculate the source to destination path. However, the manual setting need a professional solution provides to put manual path setup into practice. So administrator work and smart administrative skill is required over here. In addition, if intermediary nodes are not configured manually, then MPLS traffic does not gain importance in treated same as the regular IP or MPLS traffic. Okay, so here these are the manual path is what the limitation of the traffic engineering in the MPLS technology. Okay, apart from this, what we have the protocol dependency. The protocol dependency for automatic rerouting. If the network uses OSPF router protocol, that is open shortest path, path first routing algorithm, that is dynamic algorithm, then automatic path calculation and systematic rerouting of IP packet can be done in MPLS traffic engineering path. So what happened? The protocol dependency. Many of the networks are using their own protocols. It is not compulsory that the one is used the OSPF, one is used the BGP, one is used the IEI or maybe EIGRP. It is up to them. So it is a protocol dependency for automatic rerouting. Then our traffic is going to be rerouted to that path. Then what kind of IP mechanism is available that need to be analyzed. Once that is analyzed, then the transition to be supposed to be there from the header to header. It's all the kind of steps are going to be available. Okay. Then apart from this, performance variation in MPLS fast rerouting. The quality of service mechanism maintain bandwidth for the tunnel that operate at backup. As the intermediate node, the traffic engineering path lack manual configuration. We have discussed the manual configuration is lagging over here. That is manual configuration. Traffic using fast reroute on the alternative path will fall the link failure. So this is also possible because we have discussed the overutilization of that particular link, alternative link will be happen, can be happen. Moreover, the configuring the intermediate node in MPLS network manually is not achievable as technology lacks such options. So there is no as such automatic options available to configure the routes automatically. Okay, so that need required a manual configuration. Well, it will take more time. It will take what we can say then not that much quality and etc. Okay. Apart from this, the lack of systematic mapping is also a limitation. The dynamic mapping of IP traffic on the MPLS traffic engineering path is not achievable. This is what the limitation. The dynamic mapping of the IP traffic on the MPLS traffic engineering path is not achievable as the routers that set up path does not recognize the topology of next OSPF, let's say locals. Okay, what the it is what the lacking of what automatically understanding what kind of protocols are going to be available because the intermediate works are done at the manual level. Okay, so ultimately it is what very difficult, very tough to achieve that dynamic mapping of IP traffic to the MPLS traffic engineering. Because if this network and this net, let's say this is network and this is network, both are using the dynamic routing protocols different. So if the once is failure and then we are mapping or rerouting to this particular network, this particular path, so it is going to be a mapping is very kind of very tedious work, header transition, etc. It is what very time tedious work. So the lack of systematic mapping systems are available. But still, MPLS technology is very good, and which is taking more quality work on the traffic engineering and every private organizations. Okay, so in this video lecture, what we have discussed the limitations and the advantages of the MPLS technology in the traffic engineering, guys. So I hope this traffic engineering also concept is clear to you. We have two lectures previous with this lecture what we have discussed traffic engineering, and this lecture what we have discussed the advantages and the limitation of the MPLS technology for the traffic engineering, so that the network traffic can be managed effectively and the resource utilization and the performance can be maintained. Okay, thank you.